So for this problem, I'm hoping that you guys recognize it. And I'm hoping that you guys recognize it by me writing it a different way. E to the x raised to the second power minus 3 e to the x. I'm going to go ahead and put parentheses around this guy too, just to be a little extra here. All right. Does that look familiar to you guys? Yeah. This kind of a problem? That e to the x, if I replace that with just an x, would you know what to do? X squared minus 3x plus 2. Do you guys know what to do with this?
Yes.
You factor it, right? Okay, what multiplies to give me 2 and then adds to give me negative 3? What? Negative 2 and negative 1? Is that right? Yeah, that's right. Okay, so then I would put my x value right here and right here, but I don't have an x value. I have an e to the x value. All right, don't get scared. Okay, now what would you do next? Here, let's write what you would have on this problem over here. You would have x minus 2, then you have x minus 1. What would you do next to solve this problem? You would set each of these equal to 0. Okay, so we're going to do the same thing with this guy over here. We're going to go e to the x minus 2 equals 0, and then e to the x minus 1 equals 0. And then, so this one is e to the x equals positive 2, and this is e to the x equals positive 1. Is x alone?
No.
Nah. How do I get rid of that e? Natural log that foo. So if I natural log this foo, he dies. And I have to natural log the other side. So I'm writing natural log on both sides. Remember, whenever you log each side, you log the whole side. So x equals natural log of 2 and natural log of 1. Oh, wait a second. We can simplify that one. You can? Yeah. Log base e of 1. What power of e equals 1?
0.
Yeah, 0. I could rewrite this to be 0. That's my two answers. Oh, wait. Did I check? Is it okay? Oh, no, we don't have to check because there are exponentials right here. If I plug in natural log of 2, it would work. If I plug in 0, it would work. So, we're good. So this part is what some of you guys are saying was the hardest part, just going from here to here. And you're like, how did that happen? Well, you guys remember what to do with parenthesis exponents, like this 2 right here? What would you do with a parenthesis exponent to inside exponents? Yeah, you multiply it. Just like if you had x to the third power, y to the fifth power, if you were raising this to the second power, you would just multiply this to the inside exponents. And that's allowed because there's no addition going on inside of there. Okay, I have to say that just because a lot of people mess up on this. If I had a plus 1 raised to the second power, I cannot distribute this 2 anymore because that property no longer applies. It applies right here for this one because that essentially means x to the third, y to the fifth times x to the third, y to the fifth. And I would add these and get 6 and add these and get 10, which is the same thing you get if you multiply those guys. But anyways, all that to say, that's what happened over here. I took the 2 out. I added parentheses around this dude, like so. And then I took this 2 out so that we can see that the e to the x, we're going to treat the e to the x like we treat the x over here. Okay? All right.